All right, welcome back, guys. Hard to believe, but we are closing out chapter 6 here, and we're going to close it out with section 6.6. And we're going to kind of take a weird turn here. We've been working with equations of lines all chapter. We've been working with slope-intercept form, standard form, point slope form, rate of change slope, all that good stuff. But we're going to kind of take a turn here. We're still going to work with a little bit of lines, but what we're going to focus on in 6.6 is scatter plots. Now, what are scatter plots? Well, given a set of data that correlate together, have a relationship, you can plot those data points individually on a graph, okay? And they might not always be in a nice, neat line connecting together. Scatter plots are more used for stats. So if what we could correlate together, the temperature of the day and the amount of snow on the ground are different things. You're going to see here, we're going to do a hawk example. We have different types of hawks, and we're going to compare their length and their wingspan. And what a scatter plot is going to end up looking like is a bunch of scattered points that sometimes will have a trend in data. Other times, they'll be all over the place. And sometimes they'll almost, not just have a trend, but they'll almost make a line. Again, what does the scatter plot do? Well, I've got an x coordinate and a y coordinate, and I'm simply going to plot the point there, but I'm not going to connect the lines. I'm not trying to make a line here. My data is just going to kind of be scattered. Okay? So what we're going to do, and why we're doing it now, is you've probably seen a scatter plot before. But what we can do now that we know equations of lines is we can make what's called a trend line to estimate our data. You see, we've learned all about how to write equations of lines. Well, typically scatter plots, while they're scattered all over the place, we'll have a line called a line of best fit. Line of best fit to estimate the data. Some points will be below it, some points will be above it. Obviously, the line's more accurate the more tightly packed together the data is. So what we're going to do here is probably something you might have done before. If not, scatter plots are totally new to you. I think you'll pick up pretty quick. But we're going to, after we make our scatter plot, use a line to estimate, or we're going to use our knowledge of how to write the equations of lines to estimate a line of best fit or a trend line for our scatter plot. But enough of that, let's make a scatter plot. So how am I going to make a scatter plot? We're going to use this table to make my scatter plot. So my scatter plot is going to start like any other graph. I'm going to have my x and my y axes. I'm going to have length on the x-axis and the wingspan on my y-axis. And I'm going to come up with a scale. Probably go up by 5s maybe. And then wingspan, I will probably also go by 5s. Probably got to extend this line a little bit. Okay, so we got our scatter plot set up, or at least the axes of it. Again, how did I determine the axes? I just kind of looked at my data. I don't really have a point over 50, but my points are all minimum in the 20s, so to me it makes sense to go up by 5. Now, unlike a linear graph where we just kind of plot 2 points connected with a line, we're going to plot all these points and just kind of see what it brings. So for my first point, the Cooper's Hawk, I notice that the length is 21 and the wingspan's 36. So I'm going to go over to about 21 and go up to about where I think 36 is. So right about there. Then I'm going to do that for the rest of these points. So 2141 is the crane. If you want to pause this and try it on your own, go for it. 2141 is the crane. That should probably be right on top of the other. Okay. So 2141 is the crane. It's not going to be perfect. That's okay. 1838 is our next one. 1838. 2446. 1631. 1939. 1735. And 1946. Okay? So again, I plotted my dots, scatter plot, not a ton of points. Okay? But what I want to do here, and one of the things I can do, is I want to go ahead and kind of plot a trend line for my data. So we made our scatter plot. But what's cool about scatter plots is a trend line will estimate the data. Okay? So I want the trend line kind of to run through the middle of my data. So how am I going to do that? Well, if we look at the different data pieces we have, one of the things we can see is, looking at the different data, is we can pick 2 points, and your points might be different than mine, that maybe a line could run through to best estimate the data. The 2 that stick out to me that if I ran a line smack through them will estimate the data pretty well are those 2. What were those 2 points? Well, one of them was 1735. And the next one was 2141. Okay? You might have picked, maybe you ended up picking, I'll circle them in green, maybe you think the ones that best estimate the line are these 2. And those would be 1631 for the first one and 2446 for the last one. That's okay. You're allowed to do that, but it's going to be the same process. So we plotted our scatter plot. We picked 2 points that we think if we ran a line smack through the middle of them will best estimate our data. So if I run a line through the middle of these, I think that's a pretty good estimate of my data. Some fall above, some fall below. Okay? Then what I want to do is I want to come up with an equation for that line. Well, how do I come up with an equation for a line with 2 points? You don't remember that? Pause this video, jump back over to 6.4 and watch that one. Okay? We use point-slope form. Specifically, we'll find the slope, then we'll find or identify a point, and we'll go from there. So, what am I going to do? Well, I will start by finding the slope. So, I've got my 2 coordinate points here. I'll do y2 minus y1 over x2 minus x1. And if you're not familiar with that process or how I came up with the values for x2 and y2, x1 and y1, go ahead and flip back over to the 6.1 video or your 6.1 notes and you'll see that. When I do the subtraction, I get 6 over 4. Same thing as 3 over 2. So I've got my slope. I'm going to pick one of the points to use. And boom, I've got the equation for my trend line. Okay? Now, please be aware. Please be aware that what we are doing is estimating a trend line. This is not the best fit trend line possible, but that level of calculation for the perfect trend line will come if you take my stats class. In Algebra 1, we don't need to worry about it. Rather, what we want to get really good at is developing the equations of lines. One of the ways we can do that is pick a line that we think best fits our data and pick the 2 points that run through it, then write the equation for the line. Okay? So that's what kind of we're going to do in 6.6, all while learning about scatter plots. Now, what's cool is when we have a line of best fit, then we could actually make some predictions. Okay? Looking at my data here, if you look through the data, what you'll notice is there is no hawk that has a length of 20 inches. But given this line I created, I could estimate a hawk with length 20 inches. So how would I do that? Well, length, remember, is my x value. If I wanted to estimate the length or the wingspan of a hawk that had length 20 inches, I would simply plug 20 in for my x value, since that stands for length, and I would solve. Y minus 41 equals 3 halves times 20 minus 21. And you could solve this in a calculator. Y minus 41 equals 3 halves times negative 1. 20 minus 21 is negative 1. Which means y minus 41 equals negative 3 halves. Not negative 32, but negative 3 halves. I want to add 41 to both sides. And when I do that, I find out that a hawk with length 20 inches, and we said the hawk's length was 20, we can find out that its wingspan, aka the y value, the wingspan will be 38.5. You do that in a calculator, negative 3 halves plus 41, you will get, 39.5. And would that make sense with our line? Well, if we go back up here, looking at our line, if I went over to 20 and I go straight up, wouldn't you know it, we're probably going to be right at about 38.5. Okay, so kind of some cool applications here. Maybe it's hard for you to wrap your brain around, but what we've been doing and what we did is, to kind of talk you through, to summarize, we made a scatter plot. And then we said, you know what? Using our knowledge of lines, we could create a line of best fit for our scatter plot using 2 points as an estimate. And so we did that. We came up with y minus 41 equals 3 halves times x minus 21. Then what we did is we said we could use that equation for a line to estimate for a data point we don't know. Maybe there's a hawk out there that has a length of 20 inches, and we want to know what the wingspan would probably be. And if we run our math through, we find that we get 39.5 for the wingspan. Okay, so some cool applications here. But for you to get really good at this, we need to practice. So let's keep trying it. Let's talk about the relationship between the amount of fat in food and the amount of calories that food carries. There's a correlation between the amount of fat in food and the amount of calories in that food. Okay? So let's do the same thing. We're going to make a scatter plot given the table. Then we'll estimate it with a line of best fit. And we'll go from there. So now that you've seen this done, I would encourage you to pause the video, and I'd encourage you to try this on your own. See what you end up with. Okay? See how you do at developing this. Well, I'm going to label my x-axis as fat and my y-axis as calories. Okay? So I messed up with my scale. That's okay. We'll restart. So what we're going to do here, go ahead and plot our points. I start at 6, and I go up to 270. I go to 7, and I go up to 260. 10 is at 220. 19 is at 388. 20 is at 430. 27 is at 550. And 36, which is out here, will be at 633. Okay? So looking at that, come up with 2 points that you think best estimate the line of best fit. To me, I would say this point right here, and probably this point out here, because if I draw a line through them, it's pretty good for estimating my data, maybe a little on the high side. So the points I'm using, 36 and 633, and I'm also going to be using 7 and 260. And those are the points I am going to use to make the equation of my line. Okay? So where do I go from here? Well, from there, I need to find a slope. How do I find a slope between those 2 points? y2 minus y1 over x2 minus x1. Now, you might be sitting there wondering, Mr. Carter, you told us in the last video that the slope had to be consistent among every point, and it is not consistent among these points. You're right, but my counter argument would be that not all these points lie directly on the line. Any point, again, my line's somewhat crudely drawn. This red point here probably shouldn't be in the middle of it. But any point on this line is going to share the same slope as these 2 points. So just a quick point of clarification. All right, to find that slope, I do 633 minus 260. I get 373. 36 minus 7, I get 29. And 373 divided by 29, and I get 12.86. So my slope will be 12.86. I pick 2 points, and I go ahead and I write the equation for my line. Y minus 260 equals 12.86 times x minus 7. And there is the equation for my potential trend line that estimates the data. Again, we're making scatter plots using our knowledge from 6.4 to make potential trend lines for the data. Okay? Again, if this isn't making sense at any point, feel free to pause and shoot me an email. I'd be happy to help you. So what's our last thing with trend lines? Well, with trend lines, while we're great, we don't only want to use the trend lines to predict the data, but we want to know how accurate that prediction is. Let me draw for you a couple scatter plots here. If I have two scatter plots here, and I'll draw a trend line through them, which trend line is more accurately representing the data? Well, I hope you would probably tell me number 2 is. That red trend line's right smack in the middle of that data. That red trend line in number 1's trying to estimate the data, but it's not doing so very accurately. Not because it's its fault, but because the data is super spread out. So trend lines, while they can be great and we can make them, how accurate does our trend line become? Well, in math, we have this thing called the correlation coefficient. And the correlation coefficient is just a fancy way of saying is how good's the relationship? Is it more like number 2, where it's really strong and that trend line's doing a great job? Or is it more like number 1, where the trend line doesn't really accurately estimate the data? That correlation coefficient is going to have the symbol R, okay? And what R is going to be is R is going to be a number between 0 or negative 1. Sorry, R is going to be a number between negative 1 and 1. What's it look like if it's negative 1? Well, if it's negative 1, the data is going to be or if it's positive 1, that data is going to be in a straight positive line. That would be an example of R equals 1, a scatter plot with R equals 1. What would it look like if it was negative 1? Well, this is what it looks like when R equals negative 1, almost a straight negative line. What's it look like when R equals 0? Probably kind of like that. There's no real rhyme or reason to the data, okay? So again, we not only care about does our trend line estimate the data, which is what we did before, but how good is our trend line at estimating the data? How much data actually sits right on that trend line? If it's a strong negative line, so it really, the scatter plot data is all tightly packed, it looks like a line, but that line is going negative, it's going to be R equals negative 1. If that line looks like or the scatter plot data looks like it makes a positive straight line, it's going to be R equals 1. But if the data kind of has no rhyme or reason going on, well, it's going to be R equals 0. So what do I need you to be able to do? Well, I'm going to draw for you 4 graphs, and I'm going to give you 4 correlation coefficients. And I want you to match the graph to the proper correlation coefficient. Okay, so I'm going to draw for you 4 different graphs of data, and then you are going to match the correlation coefficient to that data. Okay, take a second, match the correlation coefficient to the data. All right, hopefully you paused the video and did that. Again, correlation coefficient tells us how accurately the trend line estimates the data, how much of the data is going to sit on that trend line. Remember, if the number's closer to 0, it's not going to look like a line at all. It's going to be all over the place. If it's really close to negative 1, it'll look like a line, but a negative line. And if it's really close to a straight positive line, it'll be close to 1. So hopefully the first one you got is 0.278 goes there. Why? Well, 0.2 is pretty close to 0. It's not close to 1 or negative 1. Consequently, we see the data scattered all over the place. Then hopefully you took the negative 0.996 over here. Again, why? Because it's a negative line and it looks pretty straight. Now the tough ask might have been determining between 0.996 and 0.723, but hopefully you had 0.996 going here and 0.723 going here, because the first graph is a little more like a straight line than the second. Okay, so in this lesson we talked all about scatter plots, and then we applied our knowledge from 6.4 to create what's called a trend line, a line that estimates the data of the scatter plot. And then we learned, well, scatter plots aren't always the most accurate thing, and the trend line sometimes varies in accuracy. So the correlation coefficient tells us how accurately the trend line is going to represent our data. Thanks for watching, folks. As always, email me if you have any questions.